Hello, everyone. Welcome to the October installment of the NWA webinar. My name is Becca Mazer, and I will be your host for today's webinar. First off, hopefully you enjoyed the annual meeting last month, and again, are hanging in there with regards to the continued pandemic. We hope everyone is staying healthy and as well as they possibly can be. If you have any comments or feedback about the annual meeting, please let the NWA know. We would love to hear what your thoughts were on especially on the virtual aspect of the meeting. Okay, a few logistics before we get started. All attendees will be kept on mute for the entirety of the talk. We certainly encourage you to ask questions along the way or send comments, and please do so using the questions GUI or the raise your hand feature in the GoToMeeting GUI. And sorry about that. Or you can go onto Twitter and ask your questions using the hashtag NWA webinar. I will then read the questions and comments at the end of the presentation. Again, you can follow along with the presentation on Twitter using that same hashtag NWA webinar, or follow the NWA account at NWAS. Lastly, this webinar is being recorded for later viewing. All right, so I'm pleased to introduce our speaker for this month, Dan Hawblitzel. He is the Science and Operations Officer at the National Weather Service Forecast Office in Nashville, Tennessee. His work focuses on the linkage between physical and social sciences, especially in ways that bridge partnerships within the weather enterprise. Recent projects include Vortex Southeast funded studies centering on risk communication involving the National Weather Service and broadcast media, and leading a statewide initiative to collaborate science and risk communication services across the state of Tennessee. Today, he will be speaking on turning mesoscale analysis into a life-saving message, moving forward from the 2nd to 3rd March 2020 Tennessee Tornado Outbreak. All right, take it away, Dan.
I'm talking today about how we can bridge basically the physical and social sciences when we're talking about mesoscale analysis, which is looking at the fine details of your meteorological environment, and a lot of important information that can be taken away from that analysis. But then how do we bridge that into effective messaging and using some risk communication and social science concepts to really make for a potentially life-saving message? And I'll be showing several examples of successful ways that has happened, and then relating it to the devastating tornado outbreak that occurred here in and around Nashville back in March, and ways in which that marrying of the physical and social sciences in retrospect could be applied to an event like what happened in Nashville, and how we can move forward to really hopefully keep something like that from happening again as far as the fatalities. So when we're talking about risk communication, most of us are familiar with the standard of severe weather risk communication, which is the Storm Prediction Center Convective Outlook. And there's a lot of great information that can be taken from this, but we have to keep in mind that this product does come with limitations. One of those limitations is that it doesn't necessarily communicate important risk communication principles. It has a strict definition. It is a probabilistic product. And here's a table expressing exactly what goes into the SPC Convective Outlook. So you've got probability of tornado, probability of wind and hail going into this. And from that, we get this wording, such as marginal, slight, enhanced risk. So that's great, and that's great information. But like I said, we have to keep in mind these limitations of this product, because there are a lot of important concepts that do not come out of this product. Some of these are what I would call understandable risk assessment. And I say that because there's a lot of research out there showing the general public and people in general don't necessarily understand these terms or even the colors that go into it. It can be confusing. You're not addressing severe weather type. Is it damaging straight line wind? Is it tornado? Unless, of course, you show those probability graphics that go into it, but even that can be confusing in itself. And then what we're really not covering are things like uncertainty, how the forecast could change, what are the impacts? And perhaps most importantly, who is at risk and what actions should they take to mitigate that risk? It's all very important information. And I will point out in this particular example, taken from the Birmingham office, they did communicate those things in this graphic, which is very important. I just happened to crop it out for this example. And when we think about risk communication, we have to keep in mind the users of our products have important decisions that they have to make. When we're talking about core partners such as emergency managers or law enforcement, they need to determine, do I need to staff up operations? Do I need to keep myself available as an emergency manager? Maybe it's a weekend overnight. Do we need to plan for emergency operations? Or do I need to delay or cancel a big event? And when we talk about the public, they have important decisions as well. Maybe they have plans that could make them vulnerable. Maybe they need to change them. Do I need to worry about taking shelter? What if I live in a mobile home where I don't have shelter readily available? And in that case, do I need to go somewhere else to stay safe? As an example of a convective outlook that might not necessarily convey these other important aspects of risk communication, take, for example, this convective outlook from Oklahoma, in which case they were expecting a supercell outbreak across central Oklahoma, which would then transition into a QLCS, where they had an enhanced risk, a moderate risk further west for that supercell outbreak, and then decreasing categories of severe risk going further east, where you expect that decaying line going down to a slight and then a marginal risk. You can show the tornado probability for that event, and appropriately you have a 15% hatched area, meaning significant tornadoes possible where you have that outbreak of supercells going on. And then as you get that transition into a quasi-linear convective system, QLCS, you get decreasing tornado probabilities, but they're not zero, and that's what's important to keep in mind. So some important things to keep in mind about using an example like this to communicate risk. Where you have those supercell tornadoes, you could have numerous long-lived tornadoes. They could be possibly strong, and that equals potentially deadly. But where you have these decreasing tornado probabilities, where you transition into this linear QLCS mode, you could still have numerous tornadoes in an environment like that. In a QLCS, they're more likely to be shorter lived, probably weaker tornadoes, so that justifies numerically these lower probabilities. But you're likely to have less lead time with the QLCS tornado. They might come with no warning at all. They spin up so fast sometimes. A lot of times they happen at night. Those factors equal potentially deadly as well. And that can be deceiving when you're only communicating these decreasing levels of risk. And just to reiterate how tornado probability does not necessarily equal your risk to safety, keep in mind where you have got supercell tornadoes. We've all seen this meme, I think, with the guy mowing his lawn with the big visible tornado in the background. Arguably, he's not as much at risk to his safety with his plenty of time to see the tornado and take appropriate action as someone maybe in this event. And this was a picture I took at a friend's wedding on that day of that convective outlook in Tulsa, which remember was in that enhanced risk with lower tornado probabilities. But a weak, quickly spinning up tornado at a big outdoor event underneath a big tent could be deadly to everyone inside. So we had to take the appropriate action and treat it as if we were further west in those higher tornado probabilities. And when you think of other populations who are vulnerable to either weak tornado winds or even straight line winds, 60 to 100 miles per hour, there's been some high profile cases in the last several years of fatalities in these types of situations. Like a large outdoor concert. We remember the Indiana State Fair from several years back. Boating, like the Branson Duck Boat, that was about 60-mile-an-hour winds that caused that. If you live in a mobile home, if you're under a big tent, or if you're in a vehicle or standing under a tree, that can be deadly, but we're not factoring that in to SPC convective outlooks. And also short lead time. If you determine that you will not have much potential to warn for a tornado, there's people that need to know that information. If you're a mobile home resident, you need to find time to leave your mobile home, putting yourself even more vulnerable out in the open while you seek sturdy shelter. A large venue takes a long time to evacuate if it's outdoors. Outdoor events like fairs, schools take a while. People with limited mobility need to take a while to get to their safe place. And so these are all important factors that we need to keep in mind when we communicate risk. And it's not just severe weather. We have to keep in mind flooding as well, because that can be very deadly. And just like the SPC convective outlook, the Weather Prediction Center, WPC, also issues their convective outlook for excessive rainfall, called the Excessive Rainfall Outlook. And just like that SPC convective outlook, this product also has a strict definition, probabilistic going into it, which is the risk of rainfall exceeding flash flood guidance within 25 miles of a point. Here's an example of a case where they had a slight risk for excessive rainfall for a town called Houghton, Michigan, up in the UP of Michigan. And they actually ended up with near catastrophic flash flooding, which washed away entire streets in this town. The downtown washed away from torrential flash flooding. So just like the SPC convective outlook, this outlook also has limitations. And I'm not saying that it's a bad product at all. It's a very good product, but we just have to keep in mind where it's limited. So looking at that and QPF, looking at a QPF forecast might not catch these small little deviations, but that small little deviation, as what happened here in the town of Houghton, could have significant consequences. So when we're using these products to communicate flash flood risk, again, we're not necessarily talking about understandable risk assessment. We're not addressing uncertainty. How could the forecast change? Yes, we're expecting 1 to 2 inches of rain, but is there the potential that someone could see 4 or 5? And if that happens, then they could be particularly at risk, even if it's just one spot. The impacts, roads washing away, cars washing away, who is at risk in a flash flood scenario, and what should they do to keep themselves safe? And when we're talking about populations vulnerable to flooding, just like we talked about populations vulnerable to wind and tornadoes, residents along creeks and streams, motorists are particularly at risk, people camping, especially if it's next to a river. Urban areas tend to flood quickly, much more so than the rural areas sometimes. And a lot of times, these people don't even know that they're vulnerable. Maybe you live next to a creek or stream that rarely floods, but that once in a 100-year flood happens, and all of a sudden your house is underwater, or you're driving around and 99% of your drive is okay, but that 1% of your drive that happens to be underwater could be potentially fatal. So how do we communicate the risk to these individuals? Well, once again, we want to keep in mind who is particularly at risk and what action should they do. Also, when should they do it? What if the forecast changes, talking about uncertainty? And also important, what's the worst someone should prepare for? Is it, even though we're expecting a slight risk of flash flooding, is there any chance that it could be worse, that you could end up with roads washed away? If so, let them know that. But you're not going to know that unless you do that thorough mesoscale scientific assessment of the environment. Combine that with understanding your user's needs and vulnerability. And when you think about this type of communication, especially the first 2 bullets, who is at risk and what should they do? We're all now used to COVID-19 risk communication. And think about what's been communicated most effectively with this pandemic. It hasn't been convective outlook. It hasn't been a probability of a certain area. Seeing COVID, the most prevalent and effective risk communication has been identifying who's at risk. In this case, older adults and those with pre-existing conditions. We all know that, and we've all been conditioned to understand that. And what should you do? If you're in that risk category, you need to take special high precautions. But even for all of us, we've been messaged time and time and time again, wear a face covering and social distance, keep 6 feet apart. And once again, who's at risk and what should you do? Would you know to wear a mask covering or to stay 6 feet apart if that hadn't been explicitly communicated to you? If you had just said there's a pandemic, be safe, would you know exactly what to do? So applying these concepts to weather, I just want to go through a few examples of how that's been successfully used around mostly the Weather Service in these examples, but it's been used all around the weather enterprise. So taking this example from Kansas City from a few years ago, the Kansas City area, they were expecting a QLCS, just like I had talked about earlier in this talk, with a fast-moving line of storms with the potential for tornadoes to spin up very quickly. Thinking about who would be at risk in that situation if we cannot get those tornado warnings out without 5, maybe 10 minutes of lead time if we're lucky, mobile home residents are particularly at risk because that wouldn't give them enough time to leave their mobile home and find shelter. So in this case, the Kansas City office messaged to their users, if they were in a mobile home or knew anyone in a mobile home, reach out to them and have them maybe stay the evening at your house until these storms pass. And it worked. If you just look at, I know this is not a scientific assessment of the effectiveness of this, but just looking at the Facebook comments, you see a lot of this. People tagging people, inviting them over, asking if they can come over. And a lot of comments like this if you were to look at the shares. So that was very encouraging to see. Here in Nashville, we applied that same concept earlier this year, same type of situation, QLCS coming through. If you live in a mobile home, and this Facebook post, note that there's not even a graphic with this Facebook post. They're just getting right off to the gist of it, what you need to do and who's at risk if you live in a mobile home. Keep in mind that you need to take a sturdy shelter, maybe stay there until the storms pass. And you get a lot of people just like this, where this individual is saying, I will be going to my pop's house. And what I'm not showing here, which is even more effective, was this was shared by surrounding offices, Huntsville, Alabama, and I think Memphis also grabbed onto this and shared the message with their users too. Again, here in Nashville, this was another QLCS event. These seem to be very challenging when it comes to messaging. This was one moving through in the middle of the night. And what we identified as a particularly vulnerable population in this case would be people who were already asleep and might not know if a tornado warning was issued, because you're not going to hear those sirens while you're sleeping. They're not designed for that. So you need to make sure you have your phone or weather radio turned on. And so this was our message. Be sure you can be warned while you sleep tonight, just in case a tornado warning is issued. And once again, just taking a non-scientific but encouraging glance at the engagement from this post, just looking at the engagement and reach from this post compared to some other ones, including the Tornado Watch. They posted the Convective outlook. And this one explicitly singling out an action for people to take reached over 750,000 people, which is quite spectacular. Compare that to much, much less reach from those other more conventional messaging methods. Duluth, Minnesota did the same thing, but they, in this case, had high winds in the forecast and thinking who was at risk. And I think this was in July, up in that part of the country. In July, you have a lot of campers and people out doing recreational activities. They singled them out. You can see in big yellow bold letters, attention campers. So right away, everyone knows who is being singled out. And then their recommended action, be prepared to act quickly, so know where your shelter options are. And they're singling out tents and RVs are not safe shelters. Just like that Nashville example, this by far was their most successful message during that event. In this case, it reached over 200,000 people, and they mentioned that that is over a third of the population of their entire area. It's very successful. Going back to flooding, going back to the Missouri area, this is an example where we want to, again, single out people with outdoor recreation. This was the remnants of Tropical Storm Bill a few years ago, moving up through Missouri. And a lot of times when you're communicating flood risk, usually the most common way of communicating flash flood risk is going to be like they did here, communicating just how much rain is expected. Again, our non-scientific perusing of the comments shows people understanding that there's going to be a lot of rain, but they're not necessarily taking the threat to life and safety all that seriously. When you look at comments like wettest float trip ever, I guess I'll grab a bar of soap and shower outside. Then the next post, they singled out actual recreational rivers that people go to, and this time provided specific action, being reconsider your float trip, or at the very least, contact the campground and make sure conditions are okay. This time, if you take a look at the shares, 4 times amount of the reach with this one compared to the QPF. And again, the comments, just people taking it a lot more seriously, tagging people, canceling their float trip, calling the campground, doing exactly what was messaged to them. So that's just a few examples of how you need to understand your users' needs to effectively message to them. And sometimes it's some complicated decisions that they need to make. I've got a boating trip planned. Is the risk of high water or high waves high enough that I should cancel it? You're telling me that we're in a slight risk of severe thunderstorms. I've got a big church outing. Should I cancel it? I'm an emergency manager. I've got an event near a river or maybe some population, and I need to consider evacuating them. Do I need to do that? They're not often easy yes or no answers to these decisions, so we have to be very effective in the way that we communicate. And that's, again, where a Meso-analysis comes in. Looking at that uncertainty, analyzing the potential worst case, such as if it stays cloudy most of the day, then our threat for tornadoes might be lower. People understand that and they appreciate that. Some parts of the country, they understand the concept of capping inversion. Maybe that's the factor behind your uncertainty. And sometimes it helps to explain that and let people understand something to look out for. Or maybe if there's more moisture out there and we're looking at a higher threat of tornadoes, these are all meteorological fine details that we need a thorough mesoscale analysis to really determine and not just rely on the models. So some examples of when these concepts have been used. Here's one from here in Tennessee. Back in 2019, we had a major flood event. This was a collaborated among everyone in the forecast office looking at the mesoanalysis together and seeing things like very deep moisture transport, deep convergence, which I've got here animated in this blue and purple. And you notice that that convergence stays over the same spots over southern Tennessee for many, many hours, which is a big red flag to heavy rain potential, of course. Looking at things like ensemble members, here's a GEFS postage stamp of every ensemble member's forecast accumulated rainfall for that event. And look how every single member, I know it's a little hard to see, but every single one showing minimum 4, as much as 7, 8, even 9 inches of rain. When we saw that every single member was showing that, we took that probabilistic information and integrated it into our messaging because we had higher than normal confidence. And here's the final product of our collaborated message in that event. We talked and we said, does this warrant the word urgent? And we said, yes. Life-threatening, absolutely. Looking at that ensemble data, is it worth saying not just possible life-threatening flooding, but we said it's likely because we had higher than normal confidence. And then a couple of impact and action statements to go along with it. Driving will be dangerous, roads are likely to wash out. And here's an action. If you live near a creek or river, be ready to evacuate if needed. And just going over again some of the key phrases that we use, like urgent, life-threatening. Note what we didn't use. We didn't even say how much rain we were expecting, which was anywhere from 4 to 7 inches. Didn't need to say it. We just got right to the point with impacts. We actually had a high risk for flooding on that day, and this graphic doesn't even mention it. And once again, just looking at the Facebook engagement from that event, here we are. That post just blew away the engagement of everything else we put out, including that high risk, including the flash flood watch, including QPF amounts. Here we have reaching almost 500,000 people with that one message. A less severe, but also particularly deadly or potentially deadly circumstance is a downburst. I talked about earlier how severe wind can be potentially fatal if you're in the wrong place at the wrong time. Well, this was far southern Oklahoma, right where I-35 crosses the Red River almost into Texas. There's a casino there that had a large outdoor concert going on. And this one lone severe thunderstorm dropped a downburst on that event. Unfortunately, it blew down the concert entrance and injured 14 people. No fatalities, thankfully, on this one. But when you look at the convective outlook, it was just a marginal risk, as it should have been, because you're just looking at isolated low-end type severe winds. So according to the SPC convective outlook, this was a very good product, a very good issuance, but it didn't get the whole point across if you were at that event. So once again, WFO Norman looked at the Meso-analysis. They identified the potential for strong downburst, looking at a sounding like this, where you've got a lot of instability, a lot of cape, a lot of downdraft cape, potential for those strong downburst winds to come to the ground. Looking at the winds here along the right side of the image, very light wind all the way up. So you're not going to have long-lived severe storms. You're going to have a disorganized updraft and downdraft. Won't affect hardly anybody, but if it does impact you, you're looking at potential 40, 50 mile an hour winds. So you do a meso-analysis like that, and you think, okay, we're looking at pulse downburst storms. So what do we know about that type of storm? We know it's difficult to assess their severity on radar. A lot of times those strong winds happen below the radar beam. Those strong winds can develop very quickly. And so even if you can see it on radar, you're not going to get much heads up at all. Usually not until it's happening. For that reason, the warning lead time is very little, if any at all, which can be important, as I talked about earlier. And even if you don't get severe winds, it's common to get sub-severe winds, maybe 40, 50 mile an hour winds in these instances. Now, if you know that you have a large outdoor event, like a large concert, well, what do you know about their vulnerability and their needs? If you've got large canopies and stages, they might not be built to withstand a 60-mile-an-hour wind, maybe not even a 40 or 50-mile-an-hour wind. So it can be dangerous even if that storm is not technically severe. Crowd control is difficult, especially if they're drinking. If you've got a lot of people out there, that can take 20 minutes or more to get everyone to a sturdy shelter. For that reason, officials need a lot of lead time. But we just identified that they're not going to get it in an event like this, in a situation with these downbursts. So putting that all together, knowing their needs and knowing what we know through our mesoscale analysis, how can you message? Something like this: we're expecting scattered storms, potential for 45 to 55 miles an hour. Know that we might not be able to provide much lead time. So if you see any storm developing, treat any storm as something that could be dangerous and start evacuating right away. And that's exactly what Norman did. This is a slide from their post-analysis of the event. And through their meso-analysis and through their understanding of the concert needs, they were able to give a 30-minute heads up of the storm potential developing. And once again, like they said here, if you're going, you might have to deviate from the severity communicated in an SPC convective outlook in a situation like this if the circumstances warrant. And so low probability, high impact events, kind of like that one, are particularly important when you need to get that message across, and it can be very complicated. That is why your mesoscale analysis matters the most in those situations. And by low probability, potentially high impact, I'm talking about maybe a tornado potential along a boundary, land spouts and water spouts, or low top supercells, low cape environments. Those are very common. Maybe you get a spin up or two, but they can be potentially deadly. Thunderstorm outflow, heavy rain along stalled boundaries that maybe not be showing up in models, pulse thunderstorms like that Oklahoma. That all requires a thorough mesoscale analysis to catch them and also understand the potential severity and assess the likelihood of that happening. It might not be likely. But if you're only relying on an SPC or WPC outlook, you might miss it because by definition, it's a low probability event. So you're likely to have a lower categorical outlook, but it could still be very high impact. And probably no better case to illustrate that this year than what occurred here in Tennessee back in March. We had a slight risk for severe storms, but in that slight risk and even outside of it, had an outbreak of tornadoes. And that started all the way in West Tennessee, crossed right down I-40 through the Nashville area and into East Tennessee. So quite a severe and devastating event. And you can see here, we heard this time and time again for people who looked at the convective outlook. It was only a 2% chance for a tornado. And that's what was communicated that morning. Now, granted, this was a low probability, but potentially high impact event if everything came together just right. And in the morning, it didn't look like it would, hence that outlook. And so just to give a little bit of personal perspective from this event, I happened to be off that day. And I, therefore, was not really looking at the weather. And I really was on the user end. I was not from the communicator side of this event. I was on the user, the receiving side. And I woke up that day, saw a 2%, which later got upgraded to a 5% to our west. And knowing, you know, these kind of get issued frequently, especially around this part of the world, I thought nothing more of it, went about my day, never checked the weather again. So I went to bed that night and thought maybe there'd be some thunder. Wasn't worried about my threat to safety. So I go to bed and I actually wake up about 2 hours later around 12:30 in the morning to my dog waking me up. He's standing on my chest because he's afraid of thunder. So he woke me up and I look over and my phone on my nightstand's illuminated, but not audibly sounding. Well, that happened to be, I thought, is someone trying to call me? And I pick up my phone and it's a tornado warning. I thought, oh, that's weird. Why didn't that sound? Well, when I go to bed, my phone automatically goes into do not disturb. And I didn't know that at least on an Android phone, that can override your wireless emergency alerts. So I relied on one method of receiving a warning and it failed me. Thankfully, my dog happened to be my second source, but of course we can't rely on our furry friends all the time. So of course, after 2 hours of sleep, I'm groggy and struggling to comprehend what's going on. like a lot of people, I don't go straight to my shelter. I seek more information. So I bring up the radar app on my phone and I see something similar to this, that red dot being where I live, and I see what looks like a supercell, and it looks like a hook echo, and it looks like it's headed right for me. And I look at the velocity data, and it's kind of complicated with some noise going around. I didn't know at the time that it's actually producing a tornado in the Germantown neighborhood of Nashville. So not being able to really comprehend what's going on here, I then step outside to look, which you're really not supposed to do, but I did it anyway. And I see this. This is a image taken from my webcam. And even then, what is that? And I thought, gosh, that's producing a lot of lightning out there. As soon as I realized it wasn't lightning, those were power flashes, and I'm looking to the southwest at a tornado on the ground, then it finally snaps that, oh gosh, I need to get right to my safe space. And so I ran to my bathroom, my interior bathroom with my dog, and thought, is the roof going to rip off? It was just weird. It was a weird situation to be in. Fortunately for me, it passed a little under a mile to my south, but unfortunately for others, it did do a lot of damage. And as that picture, that snapshot was taken, it was doing this to one of the bar districts and restaurant districts very close to my house. This was a bar and music venue that I went to quite a bit called the Basement East, just totally destroyed. Very unfortunately, 2 people did lose their lives right outside this structure. That tornado was on the ground for over 60 miles as it tore across the entire Nashville metro into the exurbs of a town called Lebanon, and then it kept going. The tornado let up a little bit, and then it got to near a town called Cookeville, which is about an hour east of Nashville, and it spun right back up, went very quickly from EF0 to EF4 in a matter of less than a mile, where it did significant damage, just totally destroying some houses out there. This was a couple I spoke to. They're standing in the spot in their house where they were when the tornado hit, and they woke up in the debris and in their yard back behind the house. She was unscathed. He had a large scratch and a bruise on his back, but they were incredibly lucky. I don't know how they did it. Unfortunately, a lot of their neighbors were not, and all in all, 25 fatalities from that event, 310 injuries. And it was quite a devastating event, and it was hard. It even hit more home for me having been on their side of the event. So just like them, I didn't know what was going to happen. I was startled. I went to bed not knowing to expect that. And so the whole time as I'm out surveying and talking to everyone, it hit more than typical, because it could have been me easily. And unfortunately for people a few blocks away, they weren't so lucky. So going back to the Meso-analysis, we like to think, is there some way that we could have communicated a higher threat for tornadoes in that event? It's hard to say. It's really hard to say, especially in retrospect. Going back and looking at the meteorological data, this was one of the model forecasts. It looked like it might have been more of a QLCS, a linear type environment. Looking at the soundings from that, you don't have much instability at all, 500-600 joules of CAPE. But when you have helicity this high, 500, 600, 700, that can overcome that low CAPE, of course, and maybe lead to the potential for potentially significant tornadoes. So there were clues. But it's hard to say that when the models aren't necessarily pointing to one discrete supercell tracking across your whole area. And even little subtle things like this, little inversion near the ground, we get QLCSs a lot in Middle Tennessee, especially in February and March. And a lot of times a little subtle inversion like that can act against tornadoes. And so I think that's what a lot were thinking this would be like them, but it wasn't. Because of that, these meteorological factors, the fact that we had a lot of factors pointing maybe against widespread tornadoes, we did only have that slight to even just a marginal risk. And I've got there denoting Cookeville, where that EF4 hit, in a marginal risk. And it's just goes to show how this might not get the whole point across. And I showed a tweet next to this graphic that came from the SPC the next morning, just explaining exactly what I had explained earlier in this talk, A categorical outlook is strongly influenced by the expected coverage of tornadoes and do not explicitly communicate intensity nor impacts. This is coming from SPC themselves. Last night appears to have been a series of tornadoes from a single supercell. So can you use the fact that it was just one supercell to justify lower probability? Sure, because that's how that product is designed. But can we say that that's it, end of sentence? No. As I'm out there talking to people, I'm saying, well, I told you there was a low threat for tornadoes. You can't say that. We've got to tell them more. And so just to think purely in retrospect, hindsight being complete 2020, just to craft, ideally, what could we have said? Not to saying we should have said this, but what could we have said if we could go back in time? I know these images might be a little difficult to look at. These are where every picture here is where a fatality occurred. Again, I'm showing the basement east. The two fatalities that occurred there, it was actually a bartender and his girlfriend. She went to pick him up when she found out there was a tornado warning to take him out of a bar without a basement to a bar with a basement. Unfortunately, the tornado hit while they were running from one bar to the other and they lost their lives. What could you have messaged in a situation like that? You wouldn't say there's a slight chance for tornadoes. Maybe you could have said, these are moving really fast. They're going to be rain wrapped. As soon as you get that warning, take immediate shelter. Don't try to go somewhere else. It's too late. Take shelter where you're at, because had they done that, they would have been okay. The bar stood. In the upper right, a very sad situation where an older couple lost their life because they were asleep. And even more tragic, they had a basement. A lot of people didn't, they did, but they didn't get to it because their weather radio was unplugged. And so they didn't get the warning. They were still asleep when it hit and they lost their lives. This was on the east side of Nashville that occurred. And then in the town of Cookeville, it's really hard to say what could or should you have done when your whole house is wiped off of the foundation, and maybe there's nothing. But you did hear from a lot of people. My phone went off and 30 seconds later, the house was gone. I didn't even have time to get to my safe space. And so at the very least, have your two ways to receive a warning would have been a message. And gosh, even something like this, if you don't have a basement, maybe consider putting on a helmet. I don't know if that's something that we would want to message all the time, but if you were to go back and say, what could I have messaged? Certainly that could have been something that you tell them. It's hard, but it just helps to steer what would have been a more effective message than just, you've got a 1 out of 5 chance of a tornado. And I'm very proud of the office. They did message exactly what we're talking about. They put out this graphic at 6:34 p.m. saying, be sure to keep your phone on and have a way to get a warning while you sleep. It will happen entirely overnight tonight. So once again, I'm very proud that our office did put that message. And I went up to the meteorologist a few days later to congratulate her. I said, that was great. Great job. Great thinking. You could have saved lives. And she just goes, I wish I would have said it louder. I wish we could have gotten that message out to more people. And, she did a great job. But the fact that she felt, you're always going to feel like you didn't do enough, but it's hard to say what you can and should have done. But moving forward, we are going to try, we all have to try to get this word out to the best degree that we can. And that requires a solid partnership with all of our weather enterprise partners. So the media, weather service, the private sector, the academic sector, to get these important messages out and determine what these messages need to be. That requires a collaborated Meso-analysis, and that requires collaborated messaging. So just to take a look at what we've done moving forward from that event, we have here in Tennessee developed a way to collaborate on Meso-analysis. And so we thought, what if just one office, if Memphis or Morristown had keyed in on the subtle little factor that maybe we should ramp up our tornado messaging? Could that have factored into the equation? You can't say in retrospect, but if it happens again, we're at least going to try. And so we developed a collaborated Meso-analysis chat room. Here's an instance from back in April. We've got forecasters from Huntsville, Memphis, and Nashville all talking here about their mesoscale analysis. And what I love about this example is they're not just talking about The meso-analysis details your CAPE, your tornado potential. They're identifying a higher potential for tornadoes, but then they're integrating that into their messaging. And you see here, I'm adding that to my near-term messaging, and someone from Huntsville says, I love this messaging coordination. So this is very promising. We are now collaborating with NSSL on warn-on forecast and maybe how this could have helped in retrospect craft our messaging leading up to that event. We've got a meeting with them coming up, I think, next week. And this is the 4Z run of warn-on forecast, which we did not see at the time. Now 4Z is 11 p.m. Arguably, this could have been, it would have been too late to catch me before I went to bed, but maybe not everyone else. But could this have been used to increase, ramp up our messaging, craft our messaging? Absolutely. And even the runs before this, before people went to bed, actually showed the threat up in Kentucky, not Nashville, but maybe there were subtle signs then that we could increase our messaging and get those critical messages out there that we talked about. I love this. This was from 2 weeks ago, how I talked about how we all need to collaborate our messaging with our partners. In this image, you have representatives of every media market in Nashville, private meteorologists in Nashville, the weather service in Nashville, and the academic sector, University of Maryland. We are all in this image collaborating a Vortex Southeast funded study on how we can all come together to share our messaging and get that messaging out to everybody. So it's not just the weather service or one station saying to leave your phone or weather radio on. We're all doing it and we're all working together. And I love this. It's not just Nashville that's happening in, it's happening across all of Tennessee that we're doing this, and even down into Alabama. So it's very, very exciting. So collaborating that meso-analysis and that messaging moving forward, what might it look like? Well, if we get another nocturnal QLCS event again, where we determine that you need to have 2 ways of receiving a warning while you sleep, imagine everybody saying that. So we've got this convergence of one important message across the state. The weather service is saying it, the social media forecasters are saying it, the broadcast media is saying it, and people get one consistent message across the state. That's our goal. We'll see next time if that's the way that we can maybe improve. And so I'll really wrap it up at that. But I know as we experiment with risk communication and with the social science, we don't yet know the best way to message. There is no one golden standard of messaging. And so people ask, what's the best way to message? There is no right or wrong answer. And so I firmly believe one of the best things you can do is collaborate. And I'm talking collaborate among your team, collaborate with all of the meteorologists in your office or at your station, collaborate with your neighbors. If you're a weather service, collaborate with your neighbors on what a good message might be. Collaborate across the sectors, collaborate with your media, collaborate with the public sector, and collaborate program areas. We've got the physical science over here, we've got the social science over here, we've got numerical weather prediction. Don't stay in your corner, work together, because as we show here, that integration of all these different types of sciences is critical to getting these life-saving messages across. And as we do that, if we get a flash flood, a freak flash flood in Michigan, a pulse downburst in Oklahoma, or even just a widespread tornado at night in Tennessee, hopefully all coming together, we can work to save lives no matter what the event. And I'll leave it at that. That's all I have. And here's my contact information in case you need it. So thank you.
Thanks, Dan. That was an incredible talk. Shows just very tangible ways to take, the scientific information and bring it to people to actually, understand their risk, hopefully a little bit better, and to take action. So thank you so much for that and sharing your personal story. I can't even imagine how terrifying that must have been. And I hope that I never am in that position myself. So we do have a couple of questions. So what other clues besides helicity would have helped to increase awareness in the mesoscale analysis?
That's a really good question. There's things that you can look at, such as the LCL height. I've seen some simulations going out there. We've worked with actually a student at the University of Wisconsin that actually showed in retrospect that that little inversion that we thought would work against tornadogenesis actually favored supercells as the preferred mode. And in that case, a supercell can plow through a little inversion like that. Can you identify that in real time? That's very debatable, but can it factor into your uncertainty and maybe a potential worst case? Possibly, possibly.
All right, how can those of us at the program level in NWS headquarters support these collaborative missions through policy as related to the collaborative forecast process and IDSS?
Yeah, that's another great question, because you actually, I think at a headquarters level, be it regional or national, really you hold the power to drive these collaborative efforts, to have that big picture view and recognize where an office might be, or where a collaborated effort between certain offices might have a lot of impact. Reaching out to an office that you think may be particularly strong with risk communication and maybe asking them to share their best practices across your region. A lot of sharing, encourage sharing. And that's one of the best things I can say is even just brown bag lunch sessions where you share best practices, I think can be very, very effective.
And very quickly, do you have, can you list off just a couple right now, a few of those best practices that you hope to include in your office in severe weather plan, or just thunderstorm plan? Because like you said, may not be, maybe a low risk or low probability, but high impact, high risk, high impact day, if that makes sense. So
Exactly.
like what do you bring to your office in terms of a plan and how to address those situations and
So that's a
communicate
very
it?
good question. Yeah, very good question. And we're still really trying to figure out the best way. And that is why we've opened it up to our neighbors to get their ideas as well, such as that collaborated Meso-analysis chat room. Because how can you capture these things? And like I said earlier, it's so hard when, you can look at the SPC convective outlook. Okay, slight risk, 5% tornado, we're good. How do you force yourself to think, is there any way that it could be more? And so that's one reason that we're pushing for this collaborated mesoanalysis, because we want to have more force ourselves to say, is there any chance that this 1 out of 5 tornado could be worse? Look at everything. What makes it a 1 out of 5 versus a 3 or 4 out of 5? And is it because the cap's too strong? Is it because the shear's too weak? And is there any chance for that to increase, for that to change? So it's a low tornado threat because the instability is too low. Okay, is there any chance for that instability to increase? And what would we need to look for that to happen? And then put that into your messaging. So how we do that consistently, I'm open to any and all ideas. We're still trying to figure it out ourselves. And so I would love to hear from others some ideas on how we can encourage ourselves to do that each and every time.
Yeah, and translating that information is probably not very easy to say a social media post, but if you have a playbook, with canned statements perhaps, which I'm sure you already do, but that in my experience in my office where I used to work, we sort of did that, and it just takes a lot of stress out of the forecaster's mind as to, oh, what do I say? And then instead be like, okay, I got this, and this factor. We've collaborated it with our offices. And so maybe we'll go and use this messaging on our social media posts. It's so hard though. And like you said, it's not one size fits all. And it just, hopefully we will continue to work on that as an agency, as a weather enterprise, really.
Exactly, as a weather enterprise, and don't try to do it on your own. That's some of the biggest advice I can give. At your media workshop, at your integrated warning team, bring it up, ask for their ideas, share ideas, and maybe as a team you can start to come up with some canned statements that you all want to communicate and say, okay, maybe next time we have nocturnal QLCS tornadoes, put in the NWS chat room, hey, NWS XXX, we're going to message this action statement, if you all want to say that on your broadcast tonight, that would be great. Even something as simple as that could be very effective.
Excellent, yes. All right, next question. Well, first of all, thank you so much for the great talk. Do you think these collaborations being expanded on a smaller scale, sorry, hold on. Okay, can these collaborations being expanded on, sorry, I'm struggling with this question a little bit. Can these collaborations expand on a smaller scale to the university campus-based meteorology safety groups there?
Yeah, absolutely. I can't think of any collaboration that wouldn't be appropriate. And, you know, we talk about the weather service and the broadcast media as maybe some of the core of the messaging aspect of a weather enterprise. There's another very important component, which is the universities. And that's why we're working with several right now. Even smaller private social media oriented meteorologists are very important. We've got a group here called Nash Severe Weather, who is strictly social media. I think it's only Twitter actually, and they're very popular around Nashville. And we're very certain to keep them in the loop, get their ideas. And so anyone who interacts with users and understands their needs to be a part of the equation, and no one left out, because you understand users' needs, you understand the science going into it, so everyone needs to be a part of the equation.
Indeed. So here's a little bit more personal twist. How much of a toll does events like this take on your mental health, both you personally and in general?
That's another great question, and you know, I'm definitely not the best to answer that. For me, it was hard seeing people suffer from an event that also impacted me, where, you know, you can talk about survivor's guilt or that kind of thing. And I've heard a lot of that in other areas. As far as, you know, the survivor's guilt of maybe having actually the tornado hit you, like what happened in Cookeville, that can be very hard to struggle with. And it's something that we have to keep in mind. So whereas for me, mine was mostly just a slap in the face of reality of what it feels like and understanding what it feels like to be on that end of the messaging. Others, it can take a dramatic toll. And when you're out surveying and you see the pain and the destruction, it's bad, and it can really take a toll. It's something that we absolutely need to keep in mind, something that we as a weather service or media need to keep in mind when we're sending out storm surveys or reporters to see that kind of thing, because it can very much hit you, and it varies from person to person. But as long as we understand as an agency that it does have an impact, and we have to be completely understanding of how it can impact people.
Yeah, and there are definitely great resources out there to help people work through events like this. And I know in the Weather Service, there's one, and I'm sure, I don't know off the top of my head, if other folks would love to share that information via Twitter, please go do so, because it's extremely vital in the recovery process for everybody. And yeah, it's tough. And honestly, one of the reasons I sort of moved away from severe weather forecasting, because the part of that would have had to be dealing with the damage surveys, and I don't know if I could have handled that. So much thanks to you all for having the courage and the strength to do the surveys, because it's only, and help the people in the aftermath, because it's only going to make them better and make our products and services at, you know, across the entire weather enterprise once again as a whole. So thank you. Have we considered maybe more collaboration between offices by using a platform like this, GoToWebinar? I think it would be helpful to be able to share each other's thoughts by by maybe showing each other screens and what we are seeing that pops out.
Yeah, and that's something that we've talked about, that with the collaborated Meso-analysis that I showed between the Tennessee offices. And I think absolutely it's something that we've never really explored before. And if there's one benefit of the COVID and teleworking, it's that it's kind of forcing us to explore new ways of electronically and virtually sharing and presenting. So I think that absolutely needs to be explored, and we've talked about it. And not just between your WFOs. SPC is another very important part of the equation. Keep your regional headquarters in the loop. It's that whole enterprise in your media too. So can maybe one office that's at the center of an upcoming moderate or high risk have a collaboration like this GoToWebinar where people can more interactively share their mesoanalysis thoughts? I think that would be a great idea.
One comment here that I would like to share. Great, inspiring presentation, Dan. Your talk highlights the need for having a mesoscale awareness of the region beyond one's own CWA, county warding area, in being able to better anticipate the unexpected. Collaboration with neighboring WFOs, weather forecast offices, and media partners certainly is a big way to foster such a goal. Good job in bringing attention to an important NWS service issue. And yes, great comments, great thoughts. And I know, in my experiences, we've been working hard to establish better partnership with all of our weather partners or folks who deal with weather and have to make, very tough decisions. So we just got to keep, like you said as well, Dan, just got to keep on keeping on and moving forward and honing those relationships. So one more question, and then we will wrap up. So why did the Tennessee offices choose to collaborate on the mesoscale on GChat, Google Chat, versus internal collaboration chat? Pros and cons. And the internal collaboration chat is weather service focused chat, if I remember correctly.
Yep, that's a great question again.
So pros and cons of that.
We chose that because you can share images and links and movies, animated. You can share a lot more different types of multimedia on a Google Chat versus the AWIPS chat. That's the primary reason. Con, obviously, being that's just one more chat room that if you're an operational meteorologist with a weather service that you've got to monitor. So I've heard both sides, the pros and cons, and we're weighing them out as we explore it further.
Excellent. Well, once again, Dan, thank you so much for your very informative talk. And again, you've provided some very tangible methods on, communicating potentially life-threatening events using more of the mesoscale analysis. And so yes, thank you so much. And also, again, thank you for sharing your personal stories. It really brings sort of a different personal perspective to, yeah, this could happen to anybody. So.
Absolutely.
And yeah, so that's all we have for this webinar. Thank you all for attending. Thank you, Hannah Strong, for all of your live tweets for today, and the webinar team for your continued work in making these webinars excellent. So stay tuned, everybody, to the newsletter, the social media outlets, your email for details on the next webinar. And again, that's all I have. Please be safe, stay healthy, do whatever you can to stay healthy, and be as well as you can be. Thank you all. Bye-bye.